So for today's video, let me introduce you to the 6 trigonometric ratios. Before we deal with the 6 ratios, I'd like us to have a quick recall on the parts of a triangle based on its side properties. So in a triangle, we always say that as long as we can see a symbol like this in the middle of our triangle, then we could consider this one as a 90-degree triangle, or in other words, a right triangle. Now, in some other orientations, it could look like this, or some others like these. Now I want us to understand that when solving the 6 trigonometric ratios, the terminologies of these sides will now change as compared to when they are on special triangles. So for this one, say for example that an unknown angle measurement is placed on here. We say that right across this symbol would be the opposite side, and then right across this symbol will be our hypotenuse. Hypotenuse. And then the remaining side of that triangle is our adjacent side. Now in another orientation like this, say for example we have our theta, or missing angle, or should I say an unknown angle measurement is right here, then we say that the side right across this symbol is our opposite side. The side right across this 90-degree symbol would be the hypotenuse. And then the remaining side would be our adjacent. Now pause the video, and I'd like you to try these two examples for when this is theta, and on this triangle, this is theta. All right. So for this example, we actually recognize that this side is right across this symbol. So we say this one is our opposite side. And then this symbol indicates that the side right across it would be our hypotenuse. And hence this would be our adjacent side. Okay, now apart from those terminologies, when understanding the 6 trigonometric ratios, I'd like us to recall identifying the parts of the triangle when one side is missing. When a side is missing, we normally would use the Pythagorean equation, c squared equals a squared plus b squared. Now with this, it is a challenge for some to identify which of the three sides is A and B and so on. So in this review, my tip would be for you to always locate this 90-degree symbol to start identifying C. The side right across that is what we call our hypotenuse, and that's going to be our C value. So this will be C. Now, sometimes the interpretation for A and B varies depending on how your triangle is positioned. So for this one could say that the base of the triangle is right here, and another would say that it's here. But does it matter? The answer is no, since this is just adding. So if you accidentally chose this side to be A or this side to be B, eventually you will still add both measurements, so the answer will still be the same. So on my perspective, I see that this triangle has this base on here. So I'll put this as B, and then the height is A. Now let's draw another triangle that has a vertical orientation like this. And so we could clearly see that the hypotenuse in this example is right across this symbol. The base is at the bottom, and the altitude or the height of the triangle, I'll say that word again, it's the altitude, so this is A. Okay. To help you recall, I'll spell it out. This will be altitude, this will be your base. Alright. Now the next part of this video would be us remembering this table for us to easily write down the 6 trigonometric ratios. Now the useful acronym, as most of us know, is SO, CA, TOA. So we start with SO, that means it's the sine function equal to the ratio of the opposite side and the hypotenuse. And then we have CA, which refers to the cosine theta function, which would need the ratio between the adjacent side and the hypotenuse. Lastly would be tangent, which has the acronym TOA. For the tangent theta, which would require the ratio between the opposite side and the adjacent side. Hence the acronym SO, CA, TOA. Now let us look into an example for this. Say for example, number 1. As we can see, it's a right triangle, so therefore we can use the concept of the 6 trigonometric ratio. In this problem, we are asked to solve for tangent of theta. If we go back, tangent theta is the ratio opposite over adjacent. So I'd like us to copy that. Tangent theta equals opposite over adjacent. And then replace your values in here based on the triangle that you have. So a suggestion, it would be best if we would label the parts of our triangle first. So as what we have reviewed, right across this symbol, the side right across that symbol would be our opposite side. So we can label this as opposite. And then right across this symbol is our hypotenuse, which is, as of the moment, is not available. And then the remaining side would be our adjacent. Now, given that we only need opposites, which is 4, and adjacent, which is 3, then we have found our final answer for problem number 1. Now let's try it with the second triangle. Let's label it again. Right across this symbol would be our hypotenuse. Right across the theta symbol would be our opposite. And then the remaining side would be our adjacent. However, in this problem, we are required to use cosine theta. So I'm gonna have to write cosine theta. And based on our table here, cosine theta is equivalent to adjacent over hypotenuse. When replaced, the ratio would become A, which is 15, and then hypotenuse, which is 25. Now, unlike 4 over 3, 15 over 25 is not yet in its simplest form. In order to do so, we would have to think of a number that could divide both 15 and 25. And that's actually by dividing both by 5. With that being said, we have our final answer of 3 over 5. And so the cosine theta is equivalent to the ratio 3 over 5. Item number 3. Going back, we say that sine theta is opposite over hypotenuse. So we can write sine theta equals opposite over hypotenuse. Now let's say this time we don't label them, assuming we have mastered finding opposite, hypotenuse, and adjacent. Right across this symbol would be our opposite side, and that tells us O is 9. Right across this symbol is our hypotenuse, which unfortunately is unavailable. So for the meantime, we would leave this bottom part of the fraction empty. And so to find the missing side of the triangle, we go back to the Pythagorean equation c squared equals a squared plus b squared. Okay, now let's identify them correctly. Right across this symbol is C. The base of the triangle, or the bottom part of the triangle, is our base. And the height of the triangle is A. Now I'm going to do the replacement. C square stays as is. A is 6 square root of 10 square plus B is 9 square. Continuing with our solution, 9 square is 81. 6 square root of 10 square, in other words, mean 6 square root of 10 multiplied to itself, and that means 6 and 6 can be multiplied, makes it 36. Square root of 10 times square root of 10 is square root of 100, and the square root of 100 is 10, and so we have 360. Now 360 plus 81 gives us 441. To eliminate the exponent 2, we square both sides, hence just giving us the value for C, and the square root of 441 is 21. That tells us that 21, which is right across this symbol, is our hypotenuse. Now looking at 9 over 21, we can reduce this further by dividing by 3 on both sides, and that gives us the final answer, which is 3 over 7. And finally, item number 4. If we label the parts, we have opposites. We don't have the hypotenuse, but we will still label it anyway. And 12 is the remaining side, which is our adjacent. Now, secant theta is not automatically part of our SOHCAHTOA acronym. However, this table will guide us in identifying the counterparts of the first 3. All we have to do is actually switch the ratios for sine, which is H over O, and that's going to give you your cosecant theta, which in other words is requiring hypotenuse over opposites. The next one is secant, which is hypotenuse over adjacent. This is our secant theta. Lastly, we have adjacent over opposite, which is for the cotangent theta. So quick tip, use this table arrangement in order for you to use the acronym SOHCAHTOA and get its counterpart, cosecant, secant, and cotangent. Now, having mentioned that secant theta is h over a, I'm just going to copy that here. secant theta equals h over a. And let's try to fill in the parts that are available. We don't have h, so we'll leave it empty. But we do have a, which is 12. That tells us that we need to compute for the missing part. C squared equals a squared plus b squared. C is missing, so we'll leave it as c squared. A is the height, which is 12. B is 16. 12 squared is 144. Sixteen squared is 256. 144 plus 256 is 400. And so we can remove the exponent 2 by squaring both sides, and c is equivalent to 20. And that gives us our hypotenuse of 20. For our final answer, secant theta is equivalent to 20 over 12 can be reduced by 4. So this becomes 5 over 3. And this is the final answer. And this concludes the video on how to use the 6 trigonometric ratios when solving for right triangles.